Hello everyone, my name is Gaurav Kumar and today onwards we start the PYQ series of control systems. So basically I am from the IIT Delhi and recently I completed MTech from IIT Delhi. So let's begin our today topics is the mathematical model of control systems. So what type of question is asked by the gate in several years? So we are seeing in the upcoming slide. So these questions is also asked by GATE in 2005 or 2006 approximately. So first question says that for the block diagram shown in the figure, the transfer function C of S and R of S is equal to. So if you remember, the signal flow graph concept is there, because if you solve by other method, then it takes longer time. So solve by Mason's formula. Okay, Mason's gain formula. So firstly we have to draw the graph. So this is 1 by S and this is the node, and this is also a node, and here is 1 by S and this is C of S. Okay, and here is the two node. Once again, one node is this and another node is this. So we have to make it clear picture of this. So firstly we make a single line, then here is the node and here is the node, and here is the C of S. So firstly this, and here is also a node, and here is, once again, 1 by S is there, and here 1 is there, and here is 1 by S is there. So this is 1 and it is connected to positive, so that's why it is take positive 1 and that is positive 1. So the Mason's gain formula says that how many forward nodes from input to output. Here is the single line from input to output is a single line, 1, 2 and 3. The path, how many paths are there? So one single path is there, another path is this, and another path is this. So three path is there. So P1 equal to 1 by S into 1 by S into 1 into 1. I am taking this path. Okay, 1 by S 1 by S 1. So 1 by S square is come, 1 by S square, and P2 second path is what? Input to output, 1 1 and 1 by S into 1. So 1 1, once again, 1 1 1 by S into 1. So it gives the result of 1 by S, and P3 is this from input to output. Okay, so from input to output, 1 into 1 into 1. So 1 into 1 into 1. So what is the result? 1. So three paths are there, and the number of individual loop means how many individual loops are there. Any closed loops are there, just like this is not the closed loop, this is also not the closed loop, because this is revert back. Okay, this is revert back. If this is like this, if I am going through and I am making this closed loop, closed path, then this loop is called individual loop. But here is no individual loop. Once again, no individual loop, so 0. Okay, and the graph determinant delta is equal to 1 minus individual loop gain, so 1 minus 0, so 1. I am thinking that you are all aware of that Mason's gain formula, that's why I solved these questions. So if we take the forward path from input to output P1, so any closed loop is formed? Not. So delta 1 is equal to 1. Similarly, delta 2 is equal to 1 and delta 3 is equal to 1. So with the help of Mason's gain formula, we can write like C of S divided by R of S equal to, well, what is written at P1 delta 1 plus P2 delta 2 plus P3 delta 3 divided by delta. Okay, so 1 by s squared into 1 by s into 1 plus 1 by s into 1. Okay, so divided by delta, so delta value is also 1. So what is the value of closed loop transfer function? Closed loop transfer function value is, if you solve this, then the value come is s squared plus s plus 1 divided by s square. Okay, so the question asked is what is the C of S divided by R of S. It is basically means by what is the closed loop transfer function of this diagram. So the closed loop transfer function of this diagram, we get, this is the transfer function s squared plus s plus 1 divided by s square. So which option is correct? Option number 2 is the correct answer of these questions. I hope you are also solved this problem previously and you make it right as like me. Okay, so come to the next question. This questions is also asked by GATE. Okay, so all the questions are related to GATE only. Okay, so if you are preparing for, if you are a electrical student, electronics and instrumentation background, then this video is helpful for you because control system is basically common subject in all the engineering branches. So given that questions saying that when subject a unit step input, okay, unit step input, the closed loop control system shown in the figure below will have a steady state error of. So basically he asked about the steady state error. So the diagram is given. Okay, diagram is given and we have to solve the with the help of what? Mason's gain formula. Mason gain formula. So I make it, you can also make it graph with your own. Here is one loop, here is another loop. Okay, and this is going to be -1. Okay, -1, and here is also a -1, and here is 3 by s is there. 3 by s, you can see like 3 by s is there, so I write it at 3 by s, and here is 2 by s plus 2, and here is 1, and it is y of s, and here it is r of s and here it is 1. So simple, r of s and y of s. So we have to find the forward path. So P1, from input to output, how many paths are there? I can see it only 2 paths are there, here to here, and this is the single straight forward line. So 1 into 3 by s into 2 by s plus 2 into 1. So after calculation 3 2 is 6 s into s plus 2. Okay, 3 2 is 6, 3 2 is 6, and this is one second, and p2 is what? P2 is from r of s to y of s minus 1 into 2 into minus 1 into 2 into s plus 2. So minus 2 by s plus 2. And how many individual loop gains are there? L1 is one individual loop gain. So here they are making a closed loop path. Okay, from minus 3 by s to minus 1, making a closed loop path. So this is the individual loop gain. So 3 by s into 2 by s plus 2 into minus 1. So it is arrived minus 6 by s into s plus 2. Okay, and if you remove the forward path p1, any closed loop is there? Not. So delta 1 is equal to 1, delta 2 is equal to also 1, because if you take forward path from 1, any closed loop forward path is making not. If you take the forward path 2, any closed loop, any individual closed loop is making not. So delta 2 is also 1. So that's why we can write like this: y of s divided by r of s equal to p1 delta 1 plus p2 delta 2 divided by delta. And what is the value of delta? Delta is 1 minus individual loop gain, 1 minus L1, and 1 minus L1, how can I write like that? 1 minus of minus 6 by s into s plus 2. Okay, so y of s divided by r of s, we can write like that: p1 6 into s plus 2 into 1 plus minus 2 divided by s plus 2 divided by delta. So what is the value of delta? 1 plus 6 by s into s plus 2. Okay, so y of s divided by r of s, if you solve this, then you have arrived at 6 minus 2s divided by s squared plus 2s plus 6. Okay, so now the question asks that what is the error? Okay, steady state value of error. So given that r of s is equal to 1, r of s value is 1, means unit step input r of s. So unit step input, the Laplace transform of unit step input is 1 by s. Okay, so we can write like y of s equal to r of s or what is the value of 6 minus 2s divided by s squared plus 2s plus 6. So basically I am cross multiplication. Okay, y of s is equal to r of s into 6 minus 2s s squared plus 2s plus 6. So now we have to remove the some portion of this solution because space is not there. you can watch this video into 2x multiple, because this solution is uh, lengthy. So you can solve, firstly you solve by your own, then see the solution. Okay, so this is beneficial for you, because in the gate examinations every time a different question is asked, not a PYQ is asked directly. The concept is repeated, but PYQ is not repeated. Okay, so think like this: first you understand the concept, then you have to solve the questions. Okay, so now y of s is equal to this, and we can write like that. What is the error value? Error is equal to what? Error is equal to E of s, we can denote as E of s equal to R of s minus y of s. Okay, so we have both the value. R of s value is what? 1 by s, and y of s value is what? 1 by s value is what? 1 by s into 6 minus 2s divided by s squared plus 2s plus 6. So if you solve this, then 1 by s is common, and s squared plus 4s divided by s squared plus 2s plus 6. Okay, so now we can find it. Lastly, what is the steady state error? So steady state error formula is what? Limit s tends to 0 s into E of s. Okay, so when we put limit s tends to 0 s into 1, E of s value is what? 1 by s into s squared plus 4s divided by s squared plus 2s plus 6. So s to s cancel, and when we put the value s is equal to 0, so this part is 0, this part is also 0, so 0 divided by anything is also 0. So what is the solution of these questions? 0. So option C is the right answer of this question. I hope this you are also solving parallelly, so your answer also should be 1, should be 0, sorry. So come to the next question. This question is very easy. Firstly you solve by your own, pause this video and solve this by your own. Okay, so basically is ask about it, what is the ask about asking about these questions. The function y of t satisfies the following differential equation, where delta t is the unit impulse function, as you all aware of that, and u of t is the unit impulse step function. Assuming 0 is initial condition, what is the y of t? So dy t of d of t, what is the Laplace transform of this? S into y of s. Okay, dy of t divided by d of t, we can write like that, s into y of s, and y of t, so we can write like y of s, and delta t, what is the Laplace transform of delta t? Is 1, because in unit impulse function the Laplace transform of unit impulse function is 1, and the Laplace transform of unit step function is 1 by s. So y of s is common, s plus 1 equal to 1. So we can write like that, y of s is equal to 1 by s plus 1. But in the question it is given that it is asked that what is the value of y of t, means Laplace inverse. So inverse of this Laplace transform, what is this? E to the power minus t. You are all aware of that e to the power alpha t is 1 by 1 minus alpha, sorry, s minus 1, e to the power at s minus a. Okay, 1 by s minus a. So similarly 1 by s plus 1 e to the power minus t is the answer. So e to the power minus t is the answer of this question, and you can write it that in zero initial condition, and u of t is the unit step function, so u of t, so e to the power minus t into u of t. So option 4 is the right answer of this questions. So come to the next question. In this question, they ask about the response of the ht of a linear time invariant to an impulse under initially relaxed condition h of t e to the power minus t plus e to the power minus 2t. The response of the system for unit step input. Okay, so it's basically ask about the response of the system, means c of s. Okay, response means c of s. Okay, just assume that this c of s, this is r of s, and this is h of s. Okay, so h of s given that e to the power minus t plus e to the power minus 2t, this is h of t. So what is the value of Laplace transform of this? E to the power minus t is what 1 by s plus 1, and e to the power minus 2t value 1 by s plus 2. Okay, and h of s value is what? C of s divided by r of s. So we can write like that, c of s divided by r of s, 1 by s plus 1 plus 1 by s plus 2. So c of s equal to r of s value is 1 by s, so cross multiply 1 by s plus 1 plus 1 by s plus 2. So c of s value is what? We can write like this na, 1 by s minus 1 by s plus 1 plus 1 by 2, 1 by 2, 1 by s minus 1 by s plus 2. Simply we converted this form into this form because of why? Because of the inverse Laplace transform exists for this equations. Okay, so c of t means Laplace inverse. We can take Laplace inverse now. So firstly, not take c of s, we can further classify this 1.5 divided by s minus 1 by s plus 1 and minus 0.5 divided by s plus 2. So Laplace inverse, what is the Laplace inverse of this? Means c of t equal to 1.5 minus e to the power minus t and minus 0.5 e to the power minus 2t. I think you are all aware of that Laplace transform, and this is u of t because all greater than 0. So what is the, which option is correct? 1.5 minus e to the power minus t minus 0.5 e to the power minus 2t. So option 3 is the right answer of this questions. Okay, come to the last part of the question number 5. This question is also asked by gate, so we can write like that, b2s divided by b1 of s is question is asked about. Okay, so what is the transfer function of b2s divided by b1 of s? So we can write like that, b2s divided by b1 of s, use voltage V2 of S divided by V1 of S. So voltage divider rule, okay, voltage divider rule. So what it say that voltage divider rule means voltage divider rule say that V2 of S equal to V1 of S into closely which is related 10 kilo ohm and 100 farad. So R plus 1 by CS plus, just like we can take as R, this is 1 by CS Laplace transform, and this is also 1 by CS, okay. So R plus 1 by CS plus 1 by CS, here is all the summation of this resistance and capacitance. So what value is comes in a numerator part? 1 plus RCS and 2 plus RCS, okay. So value is there given in the question, B1 of S, 1 plus R value is 10 kilo ohm, so 10 into 10 to the power cube. C value is what? 100 microfarad. So 100 microfarad means 10 to the power minus 6 S, and 2 plus R is given at 10 kilo ohm. 10 into 10 to the power cube we can denote as, we convert kilo ohm into ohm by 10 to the power cube, and 100 microfarad to farad 10 to the power minus 6 into S, okay. So if you solve this, V2S divided by V1 of S, so what value is come? 1 plus S, because 10 to the power 4, and here is 2 plus S, because just like 1 2 3 to 5 and 6, so 10 to the power 6 and 10 to the power 6 cancel and 1 is remaining, okay. So here all are equal to 1, and here 10 to the power cube into 10, 10 to the power 4, and 10 to the power 4 into 100, 10 to the power 6. So 10 to the power 6 into 10 to the power minus 6 is also 1, also 1. So S plus 1 divided by S plus 2 is the answer of these questions. S plus 1 divided by S plus 2 means option 4 is the right answer of these questions, okay. So this video is helpful for you guys, I think so. For all the electronics and instrumentation student, these questions are repeatedly asked every year, not the question, the concept, okay. So focus on the concept, not on the, you focus on the PYQ, okay, but concept is matter, not the PYQ question is matter, okay. PYQ concept is matter, okay. So I hope this video is helpful for you. If this